Hey, Algebra 2 students, trust you had a great weekend. This will be the last lesson that we're going to cover before our upcoming test on Friday, and that'll be lesson 78, where we're going to talk about solving quadratic equations. And we're going to take some concepts that we've learned earlier this year and apply them to some new situations that we're going to see throughout these 2 days in our lesson. Let's go ahead and review some things we've talked about before just to get our minds thinking here on this Monday morning. Some of the methods that we've used before to solve a quadratic equation. Well, first of all, what does that mean that you have a quadratic equation? That's something that you have an x squared. Well, when you had an x squared, there's three main methods that we used to solve those quadratic equations. Number one was factoring. Well, with factoring, you could look for a common factor that you can pull out to the front, or mainly you broke it down into the two parentheses, deciding did you want 2 plus, 2 minus, or one of each of the signs inside of the parentheses. A second method that I taught you this year was called completing the square. Where with completing the square, you were focused on the b value. You took half of that b value and squared it, and that was the number that you added on to both sides of our equation. Right before we started our remote learning, we learned a third method to solve these quadratic equations, and that was our quadratic formula. That's one that we had the song for. The quadratic formula, out of the list, that would be the best method to use if you were stuck on something, because the quadratic formula always works. Now, completing the square does always work, but that can be a little bit more tedious of a process, but the quadratic formula does always work for any kind of quadratic equation where you have an x squared. Well, in our lesson today, we're going to go back and focus on that first method of solving a quadratic equation, which is factoring. So let me remind us, what were the correct steps that we've used before for factoring? These will be the same steps that we're going to use today as we're working through our three examples of solving. Number one, you had to have the equation set equal to 0 before you could do anything else. We'll have to take care of that on some of the examples that we'll walk through together today, but you have to have the equation set equal to 0 before you can factor by either looking for a common factor or breaking it up into two different parentheses. And then we use what was called our zero product property. What did the zero product property tell us? Well, look at the word there. Product is a multiplication process. When you're writing things as factors, well, factors by definition are pieces that are being multiplied together. So if you have a multiplication question that is equal to 0, that's why it's called the zero product property. Well, what has to be true if you multiply pieces together and you get 0 as your final answer? Something had to be equal to 0 in your question if you got 0 as the final answer. The only way to get 0 is if you multiply by 0 somewhere in the question. That's what our zero product property tells us, and we'll see the same property being used in our lesson here this morning. Well, with our factoring, what we're going to focus on today to help us in our factoring process, and this is, I mentioned this earlier, but we're going to take the techniques that we've used before, and now we're going to extend them into these third and fourth degree equations. So they're called cubic equations if it's a third degree, and a quartic equation if it's a fourth degree. But even though they have these higher exponents, we still can use our methods of factoring to help us solve. As I was just mentioning here, the main method that we're going to focus on today to help us in our factoring was something that we learned about called the difference of two squares. Well, what does the word difference mean? You have a subtraction problem. So the sign that you have in the question is a minus sign, and on both sides of those minus sign, you have two perfect squares. This was the format that we're going to be following, the same that we followed earlier this year for our two perfect squares. Notice how the difference of squares has been factored. It's factored into two different parentheses, and inside of those parentheses, you have different signs, one plus and one minus. Why are they different signs? Because we see a minus at the end on the last term of our question. Now, what we did with the difference of squares, we looked at each term individually. So the first term, a squared. What do I square to get to a squared a? That was the first piece that was in the question, therefore it's the first piece that's going to go into our parenthesis. So in our question today, maybe it says 25x squared. Well, what do I square to get to 25x squared? For the 25, we squared the number 5, And then for x squared, we squared an x. So in the first blank of both of the parentheses, we would put 5x. What did you square to get to the first term? The same thing is true for the second term, b squared. What did I square to get to b squared? It would be b. That was the second term that was in the problem, so it's the second term that was in each of our parentheses. The two parentheses should be identical except for the sign that's in the middle. One of them is going to be a plus and one of them is going to be a minus in our question. Now notice these are always difference of two squares. What if you had in the question, you had the sum of two squares? It says a squared plus b squared. With the sum of two squares, those you can't factor over the real numbers like we're used to doing, putting them into two different parentheses. The reason for that, if you had a plus on the last term, that told you that the signs inside of your parentheses were going to be the same. They were either going to be two positive signs or two negative signs. Well, if those signs matched inside of the parentheses, then you would have had a middle term as well, something that would have just had an x. Well, now you have three pieces and you don't have a sum of squares anymore. So if you have a plus sign in between two perfect squares, those you cannot factor over the real numbers like we're used to doing. That's something that you would learn in another class in advanced math for how would you factor in that kind of situation. So today, again, we're focused on the difference of two squares. I see a subtraction problem. With that subtraction problem, there's something in the front that's a perfect square, and there's something that's in the back that's a perfect square, and that will break down into one parenthesis with a plus sign and one parenthesis with a minus sign. Don't forget, before you start your factoring method, though, your equation has to be set equal to 0. So always look for that first. Let's work through a few examples today that will look just like your lesson practice for your homework this evening. So our job is to solve. I'm going to start off with just a quadratic equation. The book will do the same for you as well, just to get us thinking along the right path. So we have 121a squared minus 64 is equal to 0. Notice this equation already equals 0, so we don't have to worry about that first step. It also is a subtraction problem, so that's exactly what I need it to be for the difference of two squares. So let's go ahead and take a look at each of these individual terms, the first one being 121a squared. Well, what can I square to get 121a squared? It would be 11a. 11 squared is 121, and a squared gives me a squared. On the second term, 64. What can I square to get to a 64? It is an 8. So the 11a would go in the first blank of both of the parentheses because it represents the first term. The 8 would go in the second blank of both of our parentheses because it represents the second term. Anytime that we have the difference of squares, when there's this minus at the end, the minus at the end told me my parentheses would have one of each sign. So I have an 11a plus 8 and an 11a minus 8, and our equation still equals 0. Now, it doesn't matter which parenthesis has the plus and which one has the minus. I usually just put the plus first, but it's fine if you had the minus first and then the plus inside of the second parenthesis. Now that we have our equation in factored format and it still equals 0, number 2, we're going to correctly apply the zero product property. Again, what did that property tell me? We just wrote a multiplication question now that we factored, and this multiplication question equals 0. The only way that a multiplication question equals 0 is if one of the factors, one of the pieces that we multiplied equals 0. Well, how many pieces have we multiplied here? There are 2. The first piece is the 11a plus 8. Notice I've set that equal to 0. The second piece is the 11a minus 8. I've also set that equal to 0 in the question. Now the directions told me to solve. What does that mean to solve? Is to figure out what the variable is on this question. On the first equation, to get the letter a by itself, I would begin by subtracting 8. On the second equation, I would have to add 8. So the first equation turns into 11a is equal to negative 8. The second equation is 11a is equal to positive 8. To finish on both equations now, getting a by itself, we're going to divide by 11. Now that would not divide out evenly, so we're going to leave our answer as a fraction. The first one would be negative 8 over 11, and the second one would be positive 8 over 11. Notice in this idea of factoring with the difference of squares, the two answers I get are identical except for their signs. Why is that the case? Because the parentheses were identical because of the signs as well. So that should happen on a majority of your questions here as you're working through the lesson. If you factored with the difference of squares, your two answers that you get from the parentheses should be the same, except one of them being positive and one of them being negative in your question. Now, before we do our last two questions with this idea of factoring, there's one note that I need us to remind ourselves of before we can get to these two questions. Yes, with factoring, we can break it down into two separate parentheses, but there was one other thing that we had to look for when factoring. It was a common factor. Now, in the last question, we didn't have to worry about that because 121 and 64 don't have anything in common. But the next two questions that we're going to walk through, the two pieces that are given to us in the original question do have something in common, and I need to move that out to the front first before I break my question down into my two separate parentheses. So let me go ahead and show you how that's going to work, beginning with this example. 400y squared is equal to 36. Well, number one, this equation is not set equal to 0, so that's the first thing I'm going to do. In order to set this equal to 0, I want to subtract 36. So I have 400y squared minus 36 is equal to 0. You always want the part, if you can, that has the variable to stay positive, and that already was the case in this question. Now that I have my equation set equal to 0, the first thing that you should always look for when you're factoring is a common factor. Well, both of the terms that I have here involve numbers. What do 436 have in common? What do they both divide by? The number 4. So I'm going to pull a 4 out to the front of our parenthesis. When I do that, let's see what's left over. 400 divided by 4 was 100. We didn't do anything with the variable because there was no variable on the second term. So I have 100y squared. There's my minus sign, and then 36 divided by 4 gave me 9, and our equation is equal to 0. So all that I did so far was pull a common factor out to the front of our parenthesis. Well, notice what I have inside of that parenthesis is our example of the difference of squares. What can I square to get 100y squared? That would be 10y. What can I square to get a 9? It is the number 3. It is the difference of squares because I have the minus sign in the middle. The common factor that we have out to the front just keeps moving down right in the question. So there's the 4 to start the problem. Remember the first term, what did we square? It was 10y, so that's the first blank in both of our parentheses. The second term, what did we square? It was the number 3, so that's the second blank in both of our parentheses, and I have 1 plus and 1 minus, and our equation still equals 0. Now, how many factors do I have at this point of the question? How many pieces are we multiplying together? There are 3. The first one is the 4. The second one is the 10y plus 3, and the third one is the 10y minus 3. We have 3 pieces that were being multiplied together, and our equation equals 0, which tells me that one of these pieces has to be equal to 0 in the question. Well, if you look at the first factor that we have, 4, can 4 equal 0? It can't. So I'm not going to use that as I'm coming up with my final answer. I'm just going to use the 2 parentheses. I'm going to say my 2 equations would be 10y plus 3. That could be where my 0 is sitting. Or the second equation, 10y minus 3, could be equal to 0. Same rough solving process as the last example. The first one, we're going to subtract 3, and the second equation, we're going to add 3. So I have 10y equals negative 3, and 10y equals positive 3. Divide both of these equations by 10. Neither one of them reduces, so let's leave them in the fraction format. Negative 3 over 10 and positive 3 over 10. 3 and 10 don't have anything in common. Don't turn them into decimals. Go ahead and leave them in their fraction format. Notice once again, we factored with our difference of squares. The answers are the same, except one of them is positive and one of them is negative. Let's do one more example where we have a common factor to pull out to the front and then continue to factor it using our difference of squares. our equation, 4x to the third is equal to 49x. So here's an example finally where I have an x to the third. The first two examples that we've done so far only had something that was being squared, like a quadratic equation. So we're going to take the same process that we just did there and apply it over here to this question. Well, what was the first step that we did in the quadratic equation? We had to have the equation set equal to 0. On this problem, to set it equal to 0, I would subtract my 49x. Now, those two aren't like terms because one's an x to the third and one's just an x. So I wrote them side by side as 4x to the third minus 49x, and our equation is equal to 0. Between these two terms, what do they have in common? Well, let's begin with the numbers 4 and 49. 4 and 49 don't have anything in common, so I can't take out a common number, but let's take a look at the variables. The first term has an x to the third, the second term has an x. This time, there is the same variable on both of the terms. When it comes to factoring something out to the front, you always took the smallest of your two variables. So I'm going to pull an x out to the front. When I did that, if I took an x away from 4x to the third, I'm left with 4x squared. Then I drop my minus sign. If I had a 49x and I took out an x, then I'm left with a 49, and our equation equals 0. Again, focused on what we have inside of that parenthesis, that's our difference of squares. What can I square to get 4x squared? It is 2x. What can I square to get the number 49? It is 7. So we can break this up into our two separate parentheses. Don't forget about that x that needs to go right down into the front. So the first blank of both of those parentheses was 2x because that came from the first term from what did I square to get to the 4x squared. The second blank in both parentheses was 7 because that's what I squared to get to the second term, which was our 49, and our equation equals 0. Notice in the parentheses, one is plus and one is minus. Always the case when we factor our difference of squares. Well, once again, how many factors do we have? There are 3. The first factor is the x. The second factor is the 2x plus 7, and the third factor is the 2x minus 7. We have a multiplication question that involves 3 pieces, and the equation equals 0. Well, that tells me that one of those 3 pieces has to be set equal to 0. The first factor that we have is x. Now, could x be equal to 0? Absolutely. The last example, the common factor was just a number, a 4. Well, 4 can't be equal to 0, but the x can. So the first equation I'm going to write down is x equals 0. The second equation came from the first parenthesis, the 2x plus 7. That could be where my 0 is sitting. The last equation comes from the last parenthesis, the 2x minus 7. That could be equal to 0 as well. Notice we have 3 different equations, and that makes sense because we have an x to the third, so that should clue us that we have 3 different answers, like we talked about back in lesson 66 about how many answers should your equation have based on the highest exponent in the question. Well, notice the first equation is already solved for x because it says x equals 0. We just need to focus on the second 2 equations to continue to solve them for x. The first step, same thing we've done in the previous examples, get rid of the constant. So the first equation becomes 2x equals negative 7 because I subtracted 7 over. The second equation, you would have to add 7. So 2x equals 7 and then divide by 2. So x is equal to negative 7 over 2 and x is equal to positive 7 over 2. Once again, we factored with our difference of squares. The 2 answers are identical except one of them is positive and one of them is negative. Now, don't forget you would need to give all 3 answers here. The first one being 0, the second one being negative 7 over 2, and the last one being positive 7 over 2. So today we focused on our difference of squares. We have that minus sign with 2 perfect squares on both sides, and that always factors into 2 parentheses, one with a plus and one with a minus. Tomorrow, we're going to look at another kind of factoring, and that's with our perfect square trinomial, and we'll see how to use that method to help us solve either a quadratic equation or something that has a higher exponent.